Okay, my first video for higher maths, okay? Differentiation. So, to illustrate this, you go y equals x squared, okay? Plus 2. So, dy by dx equals 2x, okay? So the number, which is a constant, becomes 0, okay? So you can write that as 2x, okay? Another example, y equals, keep it the other side, x cubed plus 3x minus 4. So dy by dx equals 3x squared plus 3. Okay? So the pattern you see here is 3 comes down, that loses 1. Okay? When you have a number times an x value, a constant times the variable, because it's a small change in y, dy by dx, it's changing y by a change in x, the variable x becomes equal to 1, okay? And the number becomes 0, okay? So so that's basically illustrating briefly how it works. There is a general rule. I've just looked at one or two other videos people have made in this, and they haven't mentioned the general rule, which I find amazing, astonishing, and odd. So general rule is this: if y equals x to the power n, dy by dx equals nx. So nx the n minus 1. Okay, that's what I was doing before. So when you have y equals 3x, okay, the 1 there, this to our power 1 comes down, okay, so you get 3, and then so 1 minus 1 is 0, because x to the power 1 equals x. You know, your Indices Rules, x to the power 0 equals 1, okay? So times x to the power of 0, okay? X to the power of 0 is 1, so that's why that becomes equal to 3 times 1, which equals 3. Okay, follow that? These are the Indices Rules. Indices Rules. Okay, so yeah, differentiation, that's also equal to y dash, which equals y dot, okay, which you sometimes see written. So yeah, differentiation, when you take y equals 4x squared, okay, and you write dy by dx equals 8x, okay, so 2 comes down by that rule here, n comes down, x to the n, the derivative of nx to the n minus 1, so 2 comes down, 2 times 4 is 8, and 2 minus, or maybe put the intermediate step in here, so okay, That's the intermediate step, and then it's 4 times 2 is 8, x to 2 minus 1 is 1, okay? This is actually equal to the gradient, okay? Now, in other videos you've seen, which I'm not going to name, they haven't explained what is actually going on when you do this, okay? This operation, which gives you the gradient, needs to be explained with a diagram, because this is kind of what calculus is. This is what differentiation is. It's not just this. It's not just the operation turning that into that, but you have to understand what you're doing. Okay, so this was invented by Newton and Leibniz. So if you have our okay. So when you have our okay, so that's x, y, okay. So the problem at the time, in Newton's day and Leibniz's day back in the late 1600s, was to work out the gradient at a point in the curve. This is what this is trying to do. Work out the gradient at a point in the curve. And so the gradient means that, improvised ruler, you have, if you have a line going straight through that point, okay, so it's a tangent to a curve, okay? What's the gradient at that point? So, yeah, if you have a circle, you have a tangent at some point going along through it, cutting it. What is the gradient at that point on the circle? What's the gradient at this point? And so, what Newton Leibniz came up with was this technique. They came up with a slightly more fiddly version, which allowed you to work out the gradient on the point in the curve. So it basically lets you work out gradients on hills, okay, or on curves. It's easy when you have if you have a straight line like that, okay, and you have a straight line, you can work out the gradient easily if you have 2 points here, okay, and they have corresponding x values, okay, y, x, okay. So if that's the point, say 1, and that's say 1, 2, that's say point 3, and that's perhaps the point 1, 2, 3, 4, 5, 6, and that's the point, say 1, 2, 3, 4, 5, okay? Just for the sake of trying to explain this to you. So if you have, so I've drawn out the gradient of this line, which we'll call m, okay, it's usually given the symbol m, that's the gradient, is equal to y2 minus y1 over x2 minus x1, okay? So m equals y2, which is 6, minus y1, sorry, that's x value picking, y2 is 5, minus y1 is 3, okay? Divided by x2 is, well, divided by x is the second x value, 6, minus 1, okay? This is positive, okay? Well, actually I'll show you how it works. So 5 minus 3 is 2, and 6 minus 1 is 5, okay? It's actually not a nice clean number, but that's because I picked bad numbers. But so this value is 2/5, okay, which is equal to 0.4, okay? So this gradient is, when you have a straight line, you can calculate the gradient easily by going y2 minus y1 divided by x2 minus x1. In this case, it's 0.4, okay? So that's the measure of the slope, okay? If you have a graph like this, and the slope's going that way, then the gradient would be negative, okay? Okay, so but unlike with a straight line, when you have curves, you can't do that. You can't use this formula. So Newton and Leibniz came up with a method for basically working out the slope at a point, the gradient at a point, okay? So it's that's what calculus, what differentiation is trying to do. So when you do this operation, you're trying to work out this, okay? I'm amazed other people making videos aren't mentioning this, but this is what it's all about. It's not just a case of doing this computation, you're actually trying to work out this. So when you're doing this, when you're taking a derivative, you're working out gradients. With every equation like this, an equation like 4x squared, which I gave you the derivative of, which equals 8x, is actually a parabola, okay? So something like at x equals 0, so it's going through the origin. Dy by dx is, second derivative is 8. So 8 is going from negative to positive. So it's increasing. So yeah, so the curve's a bit like this, I think. Okay. Okay. So it's actually a parabola, what you're working out with this. So if you want to, yeah. So that's basically the basics of calculus. I'll continue in another video, I think. You have to practice. Good night.